So last class we have discussed about linear regression. The formula of linear regression is y is equal to mx plus c, where x is the explanatory variable and y is the dependent variable. And there are two variables we are concentrating in this linear regression. One is independent variable. It is controlled in a scientific experiment to test the effects on the dependent variable. Dependent variable is a variable being measured in a scientific experiment. We are using slope line b and a is the intercept, and when x is equal to 0 we are predicting the y value. So that we have executed last class linear regression y is equal to mx plus c, where x is the independent variable and y is a dependent variable and c is the intercept value. We have executed the formula and we got a result for a linear regression. Today we are discussing about multiple linear regression. So multiple linear regression model, that relationship between a dependent variable and two or more independent variables. That is the only difference between linear regression and multiple linear regression. Here only dependent variable is one and two or more independent variables are there. What are the two or more independent variables like x1, x2 and so on? Those are the independent variables. Those are the predictors. Y is the intercept value and dependent variable, and b naught is a y intercept value. Slope coefficients like b1, b2 and error term we are getting. By using this formula we are calculating multiple linear regression. Then we are the second regression is a very popular non-linear regression. It is a form of regression analysis in which observational data are modeled by a function which is a non-linear combination of the model parameters. So our model name is a non-linear regression which shows the simplified version of the reality, whatever the independent and independent variables we are supplying on one or more independent variables, that data are fitted by a method of successive approximation. Example, regression trees and random forest, which are tree based non-linear algorithms. So that's why we are using in regression trees and random forest. Random forest is one of the classification model. It is based on the decision trees, and here we are using a non-linear concept like y is equal to ax square plus bx plus c, like a naught plus b1 x1 square. Even though it's modeling a curve, it's still a linear regression equation because it's in the form of y is equal to a plus bx. A non-linear regression equation can take on multiple forms like we are using a formula called ax square, like see here, ax square plus bx plus c. That is the non-linear regression. Y is equal to ax square bx plus c. So this program, last week we have executed a linear regression, same problem. To perform non-linear regression, we are taking values like where y is equal to a plus bx plus cx square, where y is the predicted test score and x is the number of hours studied, and a, b and c are the coefficients that we need to estimate. To estimate the coefficients, we can use the scipy dot optimizer curve underscore fit function directly. Here is the Python program. We usually performing a non-linear regression, like required libraries we are, because based on that equation we are supplying the values. So in this equation y is equal to bx plus cx square. A, B and C are the coefficients that we need to estimate, and x is the number of hours studied and y is the predicted test score. Required libraries we are importing like numpy as np. From scipy dot optimizer import curve underscore fit, that is directly function we are using, and define the polynomial function like function we are defining def space function c of x comma a comma b comma c. We are declaring the variables for and colon. Then we are directly using function called return a plus bx plus cx square. So we have declared a polynomial function. Now we are going to define the input and output variables. X data, we are supplying some values like number of hours studied. So under a numpy np dot array, we are declaring 2 hours 60 marks, 3 hours 70 marks, 4 hours 80 marks, 5 hours 90 marks, 6 hours 100 marks, and so on. So we are predicting y data values and x data we are supplying. That is independent variable, and y is the predicted value. Then estimate the coefficients like pop t and pop convolutional covariance. We are using the function called curve fit. Function of c, x underscore data and y underscore data. We are supplying values in that coefficients for finding. Then print the coefficient values. So those are the predicted values. Now let me execute this program. So what I am doing, so this is the equation I am using, okay, and this is the program, okay. So directly you can use Python non-linear R, okay. So here cmd cls, so notepad space non-linear R. So this is the program, you can check. So this is a non-linear regression program, okay. So what I am doing, same program we are running, Python space non-linear R. So it can predict the y values. So the predicted test scores for 7 hours, how many marks? 110 marks. If we study 6 hours, is getting 100 marks. My screen is visible, Ramchan?
Yes, sir.
Okay. So now you can open your screen and share screen so that we will execute this program. Okay.
Okay, sir.
Yeah, please share your screen. I'm logging with another account. Yeah, you can accept me. Okay. Yeah, now your screen
Yes,
is
sir.
visible. Let me check. Ah, yes. Now it is visible. Okay. Now what you have to do? Yeah, non-linear file name you can give non-linear .py. That's all. Enter. So now open. Write a hash. Write a Python program. Write a Python program to perform. Write a Python program to perform non-linear regression. Okay. So now write down import space numpy as np, import space numpy as np, enter, from scipy, from space scipy, scipy dot optimize space import, import space curve underscore fit, curve underscore fit, enter. Then hash, define the polynomial function, hash, define the polynomial function, enter, def space function func parenthesis begin x comma x comma a comma x comma a comma b comma c parenthesis close colon. No, there itself function. Yes, enter. One tab space you need to give. One tab space. Yeah. Return space a plus b multiplied b star x bx, a plus b star x, no, only one star, b star x plus c star x star star 2, that means cx square. Enter. Yeah, hash, define the input and output variables, define the input and output variables, define
Yes, sir.
yeah, now x, yeah, enter, no, starting from starting x underscore data equal to np dot array parenthesis begin square bracket begin, no parenthesis begin, no, you are giving closing, yeah, 2 comma 3 comma up to 11 you can write, 2 comma 3 comma to 11 square bracket close parenthesis close. It is array declaration. Enter y underscore data equal to np dot array, same, parenthesis begin square bracket begin 60 comma up to 150 you can write, 60 comma 70 comma. Next, hash estimate the quotients, hash estimate the quotients, COE coefficients, enter, pop t variable name pop t comma p cow cov p cow equal to curve underscore fit, curve underscore fit parenthesis begin func func comma x underscore data, no func comma x underscore data comma y underscore data. Next, hash print the coefficients, hash print the quotients, print the coefficients, print pop t, enter, print parenthesis begin, POPT parenthesis close. Yes, save the program. Now run the program. Control S. Go to
Non-linear, isn't it?
yeah, CLS, clear the screen. Not here. Yeah. Python space nonlinear.py. Yeah, some line there is a problem. Somewhere else we have done mistake.
Line number 16.
What is error name?
PCOV curve underscore fit func c comma x data underscore x underscore data comma y underscore data.
Correct.
Let me go to the program.
X underscore data comma y underscore data. Why it is not coming? Any error?
It says
Line number?
trace tag most recent call line number 16.
Same line?
Yeah, CURVE.
Oh, before function, some D letter is there.
This is the one, no, sir.
No, somewhere else it shown error. Show me that error.
This is the line. It shows error.
Pop T. Only that line.
Yes.
Okay, what is that? Can you show me that program? Show me program. POPT comma PCOV. What it is showing? PCO correct curve underscore. So line number only that 16 problem.
Yes, sir.
What it is showing? Read that error exactly. What it is showing? File. No, first line. File first line. What it is saying?
It is just
Module.
showing
Which
the
module? In module. Non-linear Python space non-linear dot py. Okay, you just close that two Python windows.
Can I close this one, sir?
Yeah, close and once again you can open. Now quit parenthesis begin parenthesis close. Non-linear. This is a separate. Same error it is coming.
Yes, sir.
Let me check.
Can I give space and check?
Where you are giving. Okay, I am sharing the code. You can see Same program it is running in my system. See, same program I'm
Okay, sir.
sending in your WhatsApp. Same you can use and paste it. It is running. Same program. You paste it in that program. Same program. Open. Import please. Yes, from there. Control V. Control S. No. Okay. Control S. Save the program.
Just a minute, sir. I'll just keep this separately.
Later you can check what is the problem. It is coming like that.
Yes, sir.
Now run the program. CLS, clear the screen. Why it is showing like that? What is the file name you have given? No. See, now it is coming. What is the problem in
Yes,
your
sir.
program? Now check this program. Open that program. Notepad space. Yeah.
I will say linear one. Okay, sir.
Okay, no problem.
No, sir.
Notepad space. Now check your program where you copied.
Wait, sir.
No, somewhere else you kept that program. Notepad file, I mean Word file, I think you saved that program. No?
Yes, sir. Yes. Yeah. Yes, sir.
You can search in
It's in my documents only. Just a minute, sir.
file name. I don't know what file name you have given. Just like that you kept, I think.
Yeah, this is the file.
Yeah, you can copy. So where is the problem? Curve underscore fit you have given, na? Same thing.
Yes, sir. Yes, sir.
Then why? Where is the problem? Check. Control S. Check that problem. No, no.
Line number 14. Here only it says it shows the error.
That's what where it is. Everything is correct only. Pop T, comma pop COV. No, no. You need to write. Hmm.
Is there a problem in the tab, sir?
Maybe, yeah, you can use tab.
It says indentation error now. So I
That
think this
means,
needs a tab.
ah, very good.
It
And
says an indentation.
next, which line?
The same error it is coming, sir.
No, you just remove everything that line and again retype. No, earlier some space problem also maybe you can You can remove that space and you can do. Okay, try this time.
Operands could not be broadcasted together with the
Because
shapes
that
10 commas.
the way you have given that it is not correct.
Which one, sir?
Uh,
These
uh,
values?
yes, curve underscore fit. Okay, that is correct. Fancy x underscore data y underscore data. 2, 3, 4. No,
Let me just
why?
compare.
Yeah, I understood now.
Yes.
Because you have missed y underscore data values. See how many values are there? Y underscore data. Check from 2 to 11. How many values are there?
There are
Count.
10 values, sir.
Below. Yes. Now check. No. How many above is there? Below how many same equivalent numbers?
10 values now.
Now save the program. Now run.
Yes, sir. Okay, now it came with the output, but there was a warning error.
Now first clear the screen. What is the warning value? Ah, once again run. Yeah, now output came. What is the warning it came?
Covariance of the parameter could not be estimated.
Covariance of the parameter. That is not a error. That is a warning. It's okay. Yeah, because of unequal combinations you have given x underscore data y underscore. Otherwise, it could have executed. Okay.
Okay, sir.
Okay. Next, we are moving to next program. That is in statistics last program. Logistic regression.
Okay, so I'll just close this.
Yeah. So we are moving to next one. Logistic regression. My screen is visible.
No, sir, no.
Oh, it is not visible. One
No,
second.
sir.
I have resume presenting. Yeah, it is coming.
Yes, sir, yes.
Yeah, third important regression is logistic regression. Logistic regression is a statistical model that in its basic form uses a logistic function to model with values like binary dependent variable, although many more complex extensions exist like 1 and 0 combination. It is estimating the parameters of a logistic model, a form of binary regression. Logistic regression is used when the dependent variable is binary in nature, like ones and zeros. So, logistic regression measures the relationship between the categorical dependent variable and one or more independent variables by estimating probabilities using a logistic function. So, which is the cumulative distribution function of logistic distribution. Like if you see the example in linear regression, we have a straight line and we have x-axis, y-axis. So here in logistic regression we have curve. Here the values output is ones and zeros. So here the values are different coefficient values. In logistic we are expecting everything output will be a ones and zeros. So like now see the example, input x values we are taking like 2 hours, 3 hours, 4 hours, 5 hours up to 11 hours, that is x1, x2, x3, x4, and probabilities like for x1 50 marks, for 3 hours 80 marks, for 4 hours, like that. This is a analogy I am explaining. So then we are getting output values like 0 and 1. So if it see if it falls, I mean below 1 the values will be 0, above 1 you can call it as a 1. So everything will be a output values 0 and 1. That's why it is called a logistic regression algorithm. So in order to develop real-time applications, so suppose any application today is rainy or not rainy. So rainy means 1 and not rainy means 0. Such type of applications we are predicting those values by using logistic regression we are solving. So required libraries like import numpy as np from sklearn. Sklearn is a library. Directly we are using linear underscore model, import space linear regression, then a hash input data hours studied, then x is equal to np dot array, and we are reshaping the values. Then output values, output data test scores like 2 hours 60, 3 hours 70, 4 hours 80, like that. Create a linear regression model and fit it to the data model called same linear regression dot fit x comma y. Print the quotients of linear regression model, and we are printing those values. Predict the test score for a new set of hours studied. Example 12 hours. How many marks is getting? Print predicted values. Okay. So likewise we are solving the problem called logistic regression. Okay. Now you can use directly that function. You can open your screen. I will explain line by line so that you can execute. Ramchand, please open your screen.
Yes, sir.
Okay. So you can notepad space logistic regression .py. That's all. Yes. Hash, write a Python program to perform logistic regression. Logistic regression. Enter. Import numpy as np. Import numpy as np. Enter. From sklearn, from space sklearn dot linear underscore model, sklearn dot linear underscore model space import space linear regression, capital L capital R, single word. Yeah, next enter. Hash input data, hash input data in the bracket hours studied, hours studied. Write down x is equal to np dot array, same parenthesis begin, square bracket begin, 2 comma up to 11, 2 comma 3 comma 4 comma, same program but we are using up to 11. Square bracket close, parenthesis close, dot reshape, parenthesis close, dot reshape, parenthesis begin, minus 1 comma 1, there itself, begin 2 times, parenthesis begin, minus 1 comma 1, parenthesis close, enter. hash output data, hash output data in the bracket test scores, test scores, enter. Y is equal to np dot array, y is equal to np dot array. In place of 2 you can add 60 to 150. Sixty, 70, 80, 90, 100, 110, 120, 130, 140, 150.
The reshape -1, 1 means columns becomes rows and rows becomes columns, isn't it, sir?
Correct, correct, correct. Correct. Next. Now enter. 1 second, why it is not coming? One second. Okay, now enter 150. So that minus 1 you can remove in y in y value. Reshape up to dot reshape you can remove. Complete reshape also remove from dot. Enter. Now hash create a linear regression model. Hash create a logistic regression model. Create a logistic regression model and fit into the data. Model equal to linear regression parenthesis begin parenthesis close dot fit fit parenthesis begin x comma y parenthesis close. Now enter hash print the coefficients of the logistic regression model. Print the coefficients, that's all. Enter. Print the coefficients. Next, print parenthesis begin double quotes begin coefficients C capital coefficients colon double quotes closes comma model dot coef single word underscore comma model dot intercept underscore model dot intercept model dot intercept underscore parenthesis close. Don't give a function. Yes. Next, enter hash predict the test scores. Hash predict the test scores. Enter new underscore x is equal to np dot array parenthesis begin square bracket begin 12 square bracket np dot array within the square bracket 12 square bracket close parenthesis close dot reshape parenthesis begin reshape parenthesis begin minus 1 comma 1 parenthesis close enter print parenthesis begin double quotes begin predicted test score within the double quotation write down predicted test score for 12 hours predicted test score for 12 hours studied 12 hours studied colon yes comma model dot predict parenthesis begin new underscore x parenthesis close two parenthesis close save the program run the program
The file name is logistic.
logistic regression.py python space it has to give the answer what is the line number
Line number 20, model.predict.
no what is error exact error
I think there is a spelling mistake in the function name, sir. Predict. It says line number 20 in the module print
okay
predicted
that
test
within the double
score.
quotation whatever model dot predict
Yeah,
spelling yeah spelling mistake is there CAT you have written
spelling mistake. D predict. This one, no? Is it
yeah
now correct, sir?
save the program now run
Yes, sir.
for 12 hours how many 160 marks
160.
yeah this is the way these three
Mhm.
programs we are executing under linear
Yes.
I mean in statistics only these three are very popular very famous for data science course that's all okay
Oh, okay, sir.
so
Okay.
now you
Okay,
can
sir.
yeah now you can see my screen I'm sharing my screen it is coming see now
No, sir.
now I have to resume
No, sir.
once again I have to resume so now so this is about non-linear regression the difference between see the difference between three regression techniques like linear regression what is meant by linear regression when there is a linear relationship between independent and dependent variables we are choosing the linear regression when we are choosing logistic regression when the dependent variable is categorical like true or false yes or no ABC XYZ in nature like a curve line so the predicted values are 0 and 1 then we can call it as a logistic regression we are choosing then if it is a polynomial regression like a non-linear regression you know non-linear regression when the power of independent variable is more than 1 yes like x1 x2 x3 x4 like that only one dependent variable and a number of independent variables like x1 x2 x3 and so on in that case like y is equal to ax square plus bx plus c okay that is non-linear regression what is linear regression y is equal to mx plus c what about logistic regression if any categorical variable dependent variable like true or false yes or no 0 or 1 abc so in that case, we are choosing the logistic regression. That is about difference between linear regression, logistic regression, polynomial. So these are the interview questions are there. Okay, how much time is there, Ramchan?
Uh, 13 minutes, sir.
So we will
1-3.
okay. We will finish this interview questions. Okay.
Yes, sir.
So what is the difference between population and sample? Population refers to the entire group of individuals or objects that share a common characteristic, while a sample is a subset of the population that is chosen for analysis purpose. Suppose India population is 145 crores. Okay, so we all are Indians as a group. Okay, individuals. We all are individuals and objects that share a common characteristics like, and we are using our national anthem as a common group characteristics. In that population, how do you can calculate sample? Suppose I am taking Tamil Nadu state. What is the population? Now that is called a sample is a subset of the population that is chosen for data analysis purpose. Then what is the purpose of histogram? Histogram is a visualization graph. It distributes a continuous variable by growing the observations into bins and plotting the frequency of observation in each bin. Like in India population, how many states are there? 32 states are there. Each state every year growing population. So you are taking as a distribution population of each state. So continuous variable because the population is continuously growing and we are observing every year it grows. So we are keeping into the bins number of bins and plotting the frequency of observation. That is called a histogram. Then what is the difference between correlation and causation? Correlation refers to the statistical relationship between two variables. How x variable is independent and y variable is dependent. By seeing linear regression, y is equal to mx plus c. In that equation, the values are predicted, y values are predicted. That is called correlation between two variables. Whereas causation refers to a relation where one variable directly influences another variable. Cause depends on COVID-19 virus, everybody getting pneumonia, some other viruses. Then what is the formula for the sample mean? By using the formula for the sample mean is sum of all observations divided by number of observations. Okay, sum of all observations divided by number of observations. What is the difference between a parameter and a statistic? Parameter is a numerical summary of a population. Okay, while a statistic is a numerical summary of a sample. When we can call it as a statistics like sum, total, average, these all are belongs to the statistic. So what is a normal distribution? A normal distribution is a bell-shaped distribution of a continuous variable that follows a specific mathematical formula. It is characterized by its mean and standard deviation. Then what is the difference between a t-test and a z-test? So these concepts belongs to probability. A t-test is used to test hypothesis about population mean when the population standard deviation is unknown, while a z-test is used when the population standard deviation is known. Then what is the purpose of regression analysis? Just now we have completed. The purpose of regression analysis is to study the relationship between dependent variable and one or more independent variables. Then what is the difference between type 1 and type 2 errors? See, type 1 error occurs when a true null hypothesis is rejected, while a type 2 error occurs when a false null hypothesis is not rejected. Then what is the difference between confidence interval and a prediction interval? A confidence interval is an interval estimate for a population parameter, while a prediction interval is an interval estimate for a future observation. Then so those are the standard questions. Sometimes you need to know it. What is the formula for sample mean? Sum of all observations divided by number of observation. So that is the answer, sum of all observations divided by number of observations. Next question. What is the difference between a type 1 and a type 2 error? Type 1 is error rejecting a false null hypothesis, while see the answer is see a
It's
type. Okay, this is a
okay,
theory
sir.
part,
Okay, sir.
theory part. So you can cover this theory part. Okay, what is the purpose of confidence
Okay, sir.
interval? To estimate the range of values in which a population parameter lies with a certain degree of confidence. Likewise, there are number of bits are there. Okay, Ramchan, you can go through it.
Yes, sir.
This is theory part. I am closing here the class. Okay, so
Okay, sir.
nearly
Okay, sir.
so many bits are there. Nearly 25 or something. So these bits you can go through it once. So with this one we are closing the statistics part. Okay, so tomorrow we will
Okay, sir.
start another module. Okay, Ramchan.